In this lesson, we're going to give a little bit of an introduction to the polar coordinate system. You can see our targets for the section itself, plot points on a polar coordinate system, and then we're going to be able to convert readily between polar and rectangular coordinates. What we know now are rectangular coordinates, of course, and then we'll talk a little bit about how to convert equations between the two. But before we get there, let's actually define the system and learn some of the basics. So over here you see a polar coordinate system. Polar coordinate system consists of a bunch of concentric circles. Each circle is centered at our polar origin. The two variables on a polar coordinate system are defined as r and theta. In other words, r is the radius. It's actually the directed radius. And we'll talk about what that means when we actually get to some examples. And theta is, of course, the angle of rotation. So our two variables, like I said, are r and theta. One thing to keep in mind about the angle is, if we harken back to what we talked about a lot of in the trigonometry that we did all year long, positive angles do turn one direction, negative angles do turn a different direction, clockwise versus counterclockwise. So that idea will come up once again in this unit. So let's jump right into some polar graphing. So we're going to plot these four polar points and discuss how to actually plot them. So what we want to do is the concentric circles are what are actually going to give us our kind of length scale. And we see we're going to do a 6, an 8, a 10, and we only have, 1, 2, 3, 4, 5 concentric circles. So we're actually going to define each circle as having unit 2. So this is 2 units from the origin. This would be 4, this would be 6, 8, 10. And you can do that as appropriate. If we were only going up to 5 or whatever, we could call them 1, 2, 3, 4, 5, whatever. But you're giving it a linear scale. Okay? So that's how that works. Now let's plot point A. Point A is 6 units from the polar origin, or the pole, at an angle of 3 pi over 4. So we find 3 pi over 4. We know it's a second quadrant angle, so there's 3 pi over 4. So what happens is you're facing in this direction at 3 pi over 4. And now we move direct positive 6 units from the pole in the angle 3 pi over 4. So there's 2 units, 4 units, 6 units. So here is point A. Point B. We are now facing the direction of pi, which is 180 degrees, of course. There's pi. And we're going to move 8 units away from the pole. 2, 4, 6, 8 units away from the pole. So there is point B. Now point C. Point C, we are now introducing a negative directed distance, directed radius. So what happens is you want to identify that you're facing in the direction of, so in other words, stand here and look in this direction. If you can picture a bird's eye view of you standing on the pole and looking at the pi over 3 sign in the distance. And if you're going to move a negative distance from there, what you're going to do is you're going to move straight away from that. So a distance of negative 4 at an angle of pi over 3 would be negative 2, negative 4. In other words, your eyes are facing this way, but you're walking back. Your eyes are facing along this way, but you're walking backwards 4 units. So there's point C. And finally, let's do point D. So let's remember how negative angles work. Negative angles are not listed on our little polar system around here. So what happens is, remember that positive angles turn counterclockwise. Positive angles turn counterclockwise. So negative angles will turn clockwise. Negative 7 pi over 6. Well, here's negative 6 pi over 6. Negative 6 pi over 6. Negative 7 pi over 6. I'm going to be right about here. So that is the direction that your eyes are facing at negative 7 pi over 6. But now you're also moving negative 10 steps, which means backwards 2, 4, 6, 8, 10 steps. So there is point D. And that's the basics of how to plot polar coordinates. Now there is one little twist to polar coordinates in that, well, polar coordinates aren't unique. In other words, point A over here, we called 6, 3 pi over 4. 6, 3 pi over 4 is not the only name for that coordinate. Now, rectangular coordinates are unique. We never had any kind of variations or anything like that. But polar coordinates can be written in at least 4 ways. 4 ways, that is, if you define the angle as being somewhere between negative 2 pi and positive 2 pi, in other words, the unit circle. I know we're super excited about that, so I'm going to ask that you continue your enthusiasm. But basically what happens is you can keep this in mind. You can have your R value or your negative R value. Remember, you can always add or subtract, that 2n pi kind of thing. You can add or subtract n pi to get different reference angles that match up and that kind of thing. So let's check out what I mean. Let's talk about this ordered pair, 2 pi over 3. So if we start here at pi over 3, here's our eyes are appearing in this direction. We'll use, since we're dealing just with 2, we'll use a 1 unit linear scale in this particular case. So 1, 2, 3, 4, 5. So the point, the ordered pair 2 pi over 3 appears right here. And like I said, this angle right here is pi over 3. Pretty straightforward. Now, what's another name for the angle pi over 3? Well, if you took pi over 3 and subtracted from it 2 pi, you would get negative 5 pi over 3. In other words, you can call this same angle 2 negative 5 pi over 3, because negative 5 pi over 3 would be that angle. If you think about that red rotation angle, you're still facing that same direction as your original blue, so it's still 2 positive units away. So there's one alternate name. And there are 2 additional alternate names for this same point, and both of them are going to begin with negative 2. So what you got to think of is, in order to be standing here and get to this blue point by moving 2 units in the opposite direction, 2 units in the negative direction, it means you need to be facing this direction. If you're facing the green arrow direction and took 2 steps backwards, you'd end up at that same original point. So what we need to do now is come up with 2 names for that green arrow. One of them is already given to us, 4 pi over 3, which we got from doing pi over 3 plus pi. 1 pi over 3 plus 3 pi over 3. Well, get you 4 pi over 3, and then we can do pi over 3 minus pi. Again, 3 pi over 3 to get you negative 2 pi over 3, which you would get by approaching the green arrow from the negative direction. And that's where that negative pi over 3, 2 pi over 3 comes in. So that's how you find all of the different names for the same polar coordinate. Hope you enjoyed this introductory lesson on graphing points, plotting points in a polar coordinate system. And in the next lesson, we'll talk about how to convert from polar coordinates into rectangular and from rectangular back into polar.